Okay, so we'll take a look at number 10 and 11. Number 10 is a fairly doable problem. Number 11 is a little longer. There's a specific reason I wanted to address something on that, in part because of my experience just dealing with my son taking calc at a university, just so seeing kind of how different people kind of interpret that. So for starters, if we're going to go ahead and take the derivative of this problem, we could jump right in and start working. But remember, the smartest thing to do with logarithms is first utilize their properties. So remember, in a log, you can actually break a division up as a subtraction question. And so really, I haven't done any calculus yet. I just did math analysis right there. And so now if I wanted to find dy dx, remember, the derivative of a natural log is 1 over u times the derivative of u prime. So like 1 over u du, if you will. So if we did 1 over u du and then 1 over u du, that technically is sufficient, although often what people would like to see, and I am going to take the second to do that, is sometimes what we're going to do is we're going to go ahead and do a little bit of extra math, and that is basically create a common denominator of 3x plus 5 times 5x minus 1. Notice that I did that. And so I'd have like 15x minus 3 here. This would be 15x, so it's actually negative 15x, and I've got a negative 5 times 5, which is negative 25. Now, again, this is just a little extra work, but it's not really that much work. I got negative 28 because these canceled over 3x plus 5 times 5x minus 1. And I think for obvious reasons, saying that y prime equals this is quite a lot nicer answer than the difference of two fractions. That's a little more straightforward. I can quickly see that this thing will always, it will never be 0. It's going to be undefined at negative 5/3 and 1/5, but it will never be 0. So that is kind of nice to know. And there will be places where it's positive and negative. But over here, that would have been a little bit more difficult to see. Okay, so this is the one we call logarithmic differentiation. This is a problem where you look at it and you go, yeah, I don't want to do that problem. That's going to be too hard because all the chain, all the quotient, all the product, all of those different pieces together look terrible. So before we ever do any calculus, it is a good idea to take the log of both sides. And that allows me to utilize properties of logs, like a multiplication becomes addition, that an exponent becomes a coefficient, that division becomes subtraction, and one more time, that exponents become coefficients. So if I took the log of both sides, that allows me to chop it up into these little bite-sized pieces. And then I know that it's 1 over y times the derivative of the inside. So remember, the derivative of a log is 1 over what's inside times the derivative of what's inside. This would be 1 over x plus 4 times 1. This would be 1 over 3x minus 1 times 3, but because of that 4, there's a 12 there. And then last, it is 1 over what's inside times the derivative of what's inside, which is a 2, but we still have that 3 in the denominator. Now, that's good. We've done our derivative, but I haven't really isolated the derivative yet because I have 1 over y dy dx. So now we can finish our problem. I'm going to write it real tight over here because I'm going to have a lot. I have 1 over x plus 4, 12 over 3x minus 1, 2 over, I guess, 6x minus 21. And then all of that stuff is going to be multiplied by y because I need to multiply y on both sides to get dy dx by itself. But I already know that y is the original problem. Now, in this particular case, I don't see a whole lot of mileage in trying to simplify that because it's going to blow up pretty rough. And so I think we're going to leave that one as it stands right now. So that was number 10. Okay, off to number 11. And honestly, this very, very similar to the problem that I asked last year. So we're going to start by finding dy dx. So this problem really has very little to do with part A, and it mainly has to do with part C that we're going to get to. And I really wanted to spend my time on part C. So let's see what we've got. So if we went to take the derivative of 4x squared, we would get 8x. That's good. Now I have a product rule because remember, we want to think of f as the first one and g as the second one. So it'd be f prime g plus g prime f. And then over here, we have to be careful because remember, 2y squared is really like 2y squared. And so power rule would be 4y to the first power times the derivative of what's inside, which is dy dx. And of course, the derivative of 40 is 0. This is not a different problem than one that was asked earlier in the review. But if we factored out a dy dx out of these two pieces right here, because these both have one, we would be left with an x and a 4y. And I'm going to go ahead and choose to bring the 8x and the y to the other side, and that's perfectly fine. And so then dy dx, of course, is negative 8x minus y over x plus 4y. Now, it is rather unfortunate that we have a bunch of these negatives sitting there. That's a little bit irritating, but it is what it is. And then over here, we wanted to take dy dx, which we already found, and we want to try to evaluate that at the coordinate 2, 3. So keep in mind, that means I'm just going to come into here, and I'm going to replace all the x's with 2, and I'm going to replace all the y's with 3. And so I got negative 19 over 14 would be the slope of that value at that moment. And so we could get any value we want, but keep in mind, because it is not explicitly defined, I can't just give you X and hope that you can get Y. In fact, if you graph this one, it actually kind of looks like an egg. It's really an ellipse, but it has been turned on its side. So because it's not a function, X is not sufficient. Now, here is where I wanted to spend the bulk of my time for this little video, because I want to try to find d squared y dx squared. And there's some work to do here. So first off, if I took the derivative of dy dx, that's how I get d squared y dx squared. So I need to take the derivative of that derivative. So I'm going to have a low d high. Now here I got to do d high. The derivative of negative 8x would be negative 8 minus the derivative of y would be dy dx minus high d low, which would be 1 plus 4 dy dx. So here's my low d high minus high d low over the square of what's below. Now, this isn't a bad answer, but it's not sufficient because, again, we have a little bit more that we could do. The first thing that I need to do is I need to go ahead and I need to replace every time I see a dy dx, I need to replace it with what dy dx is. And we already determined that that's this guy up here. So I'm going to replace it with negative 8x minus y over x plus 4y. I'm going to go here, and I, by the way, notice that there's just an awful lot of negatives there, so I decided to get rid of them, plus 4, and then instead of writing dy dx, I'm going to write negative 8x minus y over x plus 4y. And then all of this is over x plus 4y quantity squared. Now that's great, that's perfectly fine. However, that's really kind of frowned upon in math, to leave this problem where you have fractions buried inside of fractions like that. And so what you have been trained to do over the years is do what we call a fraction buster, which is to multiply the top and bottom by x plus 4y. And I get that looks terrible if we multiply the top and bottom by x plus 4y. But there is a reason why that's going to work pretty well. And so keep in mind, if you took 2 times 3 times 5, you could say that's 6 times 5. Oops, let me put this right here so you can see it. If you multiply 3 things together, which is going to happen a lot in this problem, you could say 6 times 5 is 30, but equivalently, you could say 3 times 10, because you could skip and multiply the 2 by 5 first instead of the 2 by 3 first. It's called the commutative property of multiplication. And this is why I'm going to do that. Remember, I did that to fix this, so I'm going to skip over this term and look at that term. So I also am going to fix these negative issues that are right there. So here's what we got. I've got x plus 4y. I'm going to leave this alone because I'm going to multiply it into this piece. That would give me a negative 8x, a minus 32y. This times this, again, distributive property is going to also come here. But by design, I cancel those out and I have an 8x plus y. So when this hits both of these terms, I'm now done. But similarly, when I go to multiply this into this portion, I'm going to skip over the front piece and I'm going to multiply it into this piece right here and here. So x plus 4y times 1 is going to be x plus 4y. And again, the whole reason we did that was to cancel this denominator out. So the x plus 4y's would cancel, and I get negative 32x minus 4y all over x plus 4y now cubed, because I multiplied x plus 4y on the top and bottom. Now, that may not look like I did a whole lot, but it actually did clean up a little bit, and it's worth knowing that when we do these problems, that does tend to happen, is as we go through those ways and do a couple little pieces, they tend to get a little bit better. And what I noticed when I worked through this problem is those 8x's cancel, and all that just became negative 31y, which looks quite a lot better, which means I could probably even go a little bit further. And then when I look at this step over here, I noticed in a similar way, those two things canceled, and I get negative 31x. Now, I did decide to just leave that alone right there because I got 31xy's and I'm going to have some 31xy's here, but they're both negative, aren't they? So I guess negative 62. But then I also have some y squareds and I have some x squareds. So it's not like all of these terms are going to simplify out really, really nice and pretty. But we could write it in a little bit better way, I guess, if we wanted to write it as negative 124y squared minus 248, I guess it is. Interesting, 248 x squared. And then it looks like I write here, I get negative 31 and another negative 31, so negative 62xy over x plus 4y cubed. Debatable as to which answer is the best. There's kind of good reasons why both of those could be considered to be good. So anyway, that will be it for that particular phase. I did want you to see that in simplifying it a little bit, I do think this is probably not a good way of leaving our answer, but doing a little bit of simplification was worthwhile. Okay, I will see you back in class for the next one. Bye-bye.